This is the fourth video in the series. In this video, I'll explain about linear span. So in the last video, I had explained about linear combination of vectors. There are different possible linear combinations of the given vectors. So when you collect all those possibilities, then that becomes a span of the given spanning set of the given set of vectors. So for example, if you take S is equal to V1, V2, so on up to Vn, n vectors of a vector space V over F, then the set L of S is equal to set of all. So this, just if you write alpha 1 plus v1 so on up to alpha n vn, that is just linear combination of vectors. If you collect all such linear combinations, then that becomes a spanning set or linear span of the set. Yes. See, for example, you take up a set S is equal to 1, 0 and 1, 1 of R square. So there are different possible linear combinations like 1 into 1 comma 0 plus 1 into 1 comma 1. So that gives you 1 plus 1 2 comma 1. So it goes to 2 comma 1. That's one possibility. Here I have taken one more possibility like alpha equal to 2, beta equal to 2. So that goes to 4 comma 2. So this is here, that goes to the resultant 4 comma 2. 2 comma 1, then comes 4 comma 2. So then change alpha and beta, any value you give for alpha and beta. So you will get different possibilities, different answers. So collect all those answers, put it in this set, that becomes linear span. So collection of all those vectors which are linear combination of the given n vectors will give you the linear span. So the now linear span of these two vectors is nothing but alpha plus beta comma beta, where alpha and beta belongs to R. This is how to represent the linear span. So when you take linear span of I cap and j cap are unit vectors in the along the x and y axis respectively. When you take the linear span of that 1 comma 0 plus beta into 0 comma 1, that gives you alpha comma beta. Alpha of x comma y, you know that any point in R square is nothing but x comma y represented as. Alpha beta belongs to R. So linear span of these two vectors, they are the standard vectors. These two vectors is the entire plane R square. That means it goes to each and every vector. The linear combination of these two vectors will not leave any point in the entire plane. It goes to each and every point. So that is called its linear span. Similarly, linear span of 1, 0 and 2 comma 0. Okay, so these are the 2 points on the x-axis. Okay, when you take the linear combination of any two vectors on the x-axis, the resultant is also on the x-axis. It won't go anywhere. So when you scale a vector on the x-axis and add any two vectors on the x-axis, answer is also in the x-axis. That's why linear span looks like alpha plus 2 beta comma 0. Y coordinate 0 means it's again a point on the x-axis. So this is called as linear span. Now how to check whether the given vector belongs to the linear span of the given set? There are different methods. I'll go with those problems later. I'm making you to understand the concepts first. So this is what linear span means. It's all possible combination, linear combination of given vectors. Collect all those possible linear combination, that becomes a linear span. And one more important thing is linear span of S is the smallest subspace. It is also a subspace, the containing S. Okay, so that is one important theorem or result which can be derived from the concept of linear span. So this is the meaning of linear span. Collecting all those possible linear combinations will give you the entire set linear span. Thank you for watching.